Alright, this is GSRT 8. This video deals with worksheets 1, 2, and 3. And ultimately we just continue in the world of trigonometry, but we're now looking at word problems. And so mostly what I'm going to do here is kind of try and do my best to explain what some of these words mean. The first thing that they talk about, or is a very common word in trig problems, is the angle of elevation. You see the word elevate means upward, right? Or elevator. So basically the angle of elevation is from a horizon up, upwards. So that could be if you're standing on top of a street or on a street looking up at a bird or something, the angle of elevation would be here. It would also be true that if you're on top of something, now watch this, this is a little bit different. The angle of elevation would be from your horizon up here. Notice this isn't down at ground level, the person's not at ground level, so they're up here, so their horizon up. In this case, we're looking at a plane from the island. That little guy sitting down there on the island is looking up at that plane at an angle of elevation. This is the angle of elevation, looking upward from the horizon to the plane. Now the one that's more difficult than elevation is depression. It will often say, you know, from the plane looking down at an angle of depression. So if you're depressed, you're down, aren't you? You're sad, you're feeling down, and so it's the same way. I would also say it's from the horizon downward as well. This is harder for students to visualize. Here it's pretty obvious. If I'm at the plane and I'm looking at an angle of depression, I'm looking in a downward direction. Now why this one's trickier is what happens is a problem like this. It'll say, you know, Sally is looking at a car at an angle of depression of, say, 15 degrees. A lot of students will place the 15 degrees here, and the reason is obviously that's where it goes. You have a triangle, there's Sally looking down, the 15 goes here. This is wrong. It's an error, a big time error. And that's why it's trickier. Where the angle of depression should go, if they say it's 15 degrees, would be right here, because that's from the horizon down. So that's why it's up in that corner. Now if you don't like this situation, if you don't like working in a triangle up here, which you can do, you can also bring that 15 down here. These parallel horizons, lines, are parallel, so alternate interiors are equal, so you would know this is 15. Another way, if you don't like working with that 15, instead of putting it here, which is wrong, you could subtract 15 from 90, and you could put a 75 there, because 75 and 15 make the 90 degrees. So you got a couple of options. The other thing I want to do with you is walk you through some of the typical language used in word problems dealing with trig, and just talk you through them. Ladders are often used that are leaning against a wall, partly because you get the right angle here. You've got the ladder here. This, of course, is the wall. Sometimes they'll talk about reaching a window. You have the foot of the ladder. This distance is from the foot to the wall, that kind of thing. The angles would be referred to, this angle would be the angle between the ladder and the ground, or the degree that the ladder is leaning. Up here they would name this angle to be the angle between the ladder and the wall, that kind of thing. The kite problems are classic. Now there's a couple of assumptions that are made in a kite problem. First of all, the string we assume to be straight, not wavy like this. The other thing we assume is that actually we are basically flying it from kind of the foot of the person. there would be a few more calculations needed if we were working off of his hand, and a few things. We'd need to know how high it is off the ground and things like that. If that's provided, then we do that, but generally we will work on an angle here. This of course is the string. This would refer to the height of the kite, and this would be the ground distance, or the distance from the person to under the kite. Another classic is the guy wire. The guy wire, I'm not sure why it's called that, but basically is a wire that attaches to a tree or a tower or something like that. If you've got an antenna, sometimes you will attach that to the ground to keep it from blowing over or breaking or whatever. This of course would be the height that it's attached to it. This would be the ground distance. Again, we assume trees grow 90 degrees, that kind of thing. Here we're talking about the sun and its rays. This would be the angle that the rays form with the ground. We always would have a shadow down here. That's part of what's happening, is the shadow is cast onto the ground, and this of course would be the height of the person. Here you would have you could have a couple different situations. Usually this one is about an airplane looking down at an angle of depression at the island. And again, you can do a couple of things here. This is known as the altitude of the plane, right? The total height of the plane, the altitude. And then this is known as the ground distance, or sometimes would be just distance, basically till it flew over the island, that kind of thing. So again, just translating different types of words. This is often called the line of sight. So looking directly to the island. Well, let's do a couple of these. Let's show you how to try a problem or two. I'm going to go through quickly through these just to get a little sense. I always like to draw a diagram. You should always draw a diagram. It says there's a guy wire attached to a tree. So let's quickly do that. Let's attach our guy wire to the tree. The guy wire is 3.4 and it's attached to a tree 3 feet up. So there it is. What's the angle formed between the wire and the ground? That's down here. So we set this up. This is our opposite side. This is our hypotenuse. This is the sine ratio. The sine of the angle is equal to opposite over hypotenuse. And then again, when I'm finding the angle, I always use the inverse function. And I'll quickly do this calculation here on my calculator. So second sine, 3 divided by 3.4. And we get, I get in the calculator, 61.93. This says to round it to the nearest degree, so we're going to do that, 62 degrees. Okay, next one. A 15-foot ladder leans at an angle of 52 degrees. So we have some wall or something. We have our ladder leaning at an angle of 52 degrees. The ladder's 15 feet long. And it says how far from the wall to the foot of the ladder. So we want this here. So this is our adjacent side. This is our hypotenuse. That would be a cosine relationship. Cosine of 52 is adjacent over hypotenuse. Cross multiply, we get the cosine of 52 times 15. And again, I'll use my calculator. Cosine of 52 times 15 gives me a value of 9.23 feet, and it says rounded to the nearest foot, and so we're going to say that's 9 feet. Alright, let's keep going. The sun's rays, so we got some sun going on here. We got some ground. What do we got here? Is it a tree? What do we got? A tree, yes. So we got some tree. The rays from the sun travel down, strike the ground at 55 degrees, 21 meters from the base of the tree, so it hits at 21 meters away, and they would like us to know what is the height. So again, we've got our tree here. We want to know its height. This looks like an opposite and an adjacent. So this is tangent of 55 is opposite our height over our given adjacent. Cross multiply. It's the tangent of 55 times 21. And our height is the tangent of 55 times 21. Gives me 29.99. What are we dealing with? Meters. And it says round it to the nearest one. Well, that's easy there. 30. Okay, keep going. I want to get all of the couple of varieties in here, so I'm moving quickly. Little boy flying his kite. Here's our little boy. Flies his kite. I'm going to tie it to his toe to make it easy. It's an angle of 37 degrees. Let's see, stands by, from where he stands to directly under the kite is 45 feet. And it says, how long is the string? Here's our string to our kite. So this looks like, what do we got here? This is our adjacent and this is our hypotenuse. And so this is cosine of 37 equals 45 over x. This time when we cross multiply, we get the cosine of 37 times x equals 45, and then finally we get 45 divided by the cosine of 37. This value gives us 45 divided by the cosine of 37, gives us a value of 56.35, and they ask us to round it to the nearest foot, so we would say 56 feet is the length of our string. Almost there, 2 more to go. 10-foot ladder reaches a window, so we got some sort of a building with a window, and our ladder is up to that window. 10-foot ladder reaching a window that's 8 feet up. What is the angle formed between the ladder and the wall? That's in here now. So this is our adjacent side and our hypotenuse. That would be cosine of an angle is adjacent over hypotenuse. Cosine, the inverse of cosine, will give us our answer. When we hit second cosine of the ratio 8 is to 10, we get 36.87, and it says round it to the nearest degree, 37 degrees we're looking at. Finally, we got an airplane spotting some floating debris, so we got some water out here going on. We got our little airplane over here spotting, I don't know, some sort of floating box of some sort, and spots it at an angle of depression of 15 degrees. The plane is at an altitude of 3,000. And what else do we know? Let's see. Find the horizontal distance. That would be over here. So I'm going to work in this lower triangle. I'll bring the 15 down, and we're looking at tangent. Tangent of 15 is opposite over adjacent. Cross multiply, we get the tangent of 15 times x equals 3,000, and x equals 3,000 divided by the tangent of 15. And so our answer, it's going to be a big one, 3,000 divided by the tangent of 15 gives us 11,196.15. They ask us for in the nearest hundreds, that's the hundreds there, so 11,200 feet is the ground distance, or the distance I need to travel before I'm over the debris. Well, there's a couple examples for you just quickly to show you how to do these.